Okay, so today we're going to be doing the quadratic formula again, but this time the discriminant is not going to be a perfect square. I'm going to get irrational roots. And remember, if we get irrational roots, like let's say the square root of 20, we're going to break that down into whatever roots we can. So if I get, let's say 4 and 5, I can take the square root of 4, which is 2. I cannot take the square root of 5, and I'm going to leave that behind. And we're going to get some aspect that looks like this. And the cool part about irrational roots is that if one's irrational, so is the other. Because remember, we're looking for the distance. So if I know the distance over here is some sort of square root, I know the distance on the flip side is also going to be a square root. One irrational root comes with a pair with another irrational root. That is a general rule that will be applied. So each one of these is going to have 2 irrational roots. So let's go ahead and get started. The same process applies today as yesterday. We're going to take the quadratic formula, which is negative b over 2a, and we're going to add and subtract the discriminant, which is b squared minus 4ac. I'm going to take the square root of that. All we need is I need to know my a, my b, and my c. A is the number in front of x squared, b is the number in front of x, and c is the number with no x. So let's go ahead and plug that in and see how we do. So negative plus or minus 4ac over 2 times a. So that's a negative b plus b squared minus 4 times a times c all over 2a. So it's negative 8 plus or minus, let's see, that's a 64 minus 44 over 2. Oh, lo and behold, our first example is going to be the same thing as up here. So x equals negative 8 plus or minus the square root of 20 all over 2. And so what we're going to do is we're going to take a quick pause and take the square root of 20 and see if we can't reduce that. We already know that 20 breaks down into 4 and 5. I can take the square root of 4, which is 2. I cannot take the square root of 5, so I'm going to leave that. So I'm going to rewrite this as x equals negative 8 plus or minus 2 square root of 5 all over 2. And then the last thing that we're going to do is we're going to check out, hey, I'm going to use blue for this, can I reduce this fraction? And the answer is yes. Both 8 and 2 both divide by 2. So negative 4 plus or minus 1 square root of 5. Now, with this, typically speaking, this is going to be where we stop. You could split it, but remember, this doesn't reduce any further. So if you split it, you're just going to be writing out. Let's split this. So that would be x equals negative 4 plus the square root of 5, which gives me that right root, and x equals negative 4 minus the square root of 5, which is going to give me the left root, which is no different than what we were showing right there. So let's do one more of those. So what we need is I need to know my a, my b, my c. A is the number in front of x squared, b is the number in front of x, and c is the number with no x. I'm going to plug it into the formula, which involves taking the vertex and then adding and subtracting the discriminant. There we go. Let's plug in our values. Negative 8, 8 squared, negative 1, 15, negative 1. If we start simplifying this, it's going to be a positive 4 times 15 is going to be a positive 60. Okay. X equals negative 8 plus or minus the square root of 124 all over negative 2. And again, we're going to take a quick pause. Square root of 124. We're going to break it down. So I noticed in this case, 4 goes into 12 and 4, which is going to be 31. I can take the square root of 4, which is 2. I cannot take the square root of 31, which means that that can be broken down into x equals -8 plus or minus 2 square root of 31 all over -2. We're going to ask ourselves if I can reduce both the tops, and yes we can. X equals -8 divided by -2 is going to be a +4. 2 divided by -2 is going to change the sign. So you can either leave it as plus minus because I'll still have a plus minus, or if you want to be super fancy, you could say minus plus. Really, there's no difference between minus plus and plus minus. You have one of each. If you wanted to split it, basically what would end up happening was you would have an x equals 4 minus the square root of 2 times 31. Oh, hold on. 2 doesn't exist because 2 divided by 2 is 1, which means that this doesn't exist. It's just 4 minus the square root of 31. And my other one would be x equals 4 plus the square root of 31. You have your two answers. There we go. So I want you to take that as an example. I want you to pause the video, try out number 5, resume it when you're done, and see how you did. Okay, so let's get down our A, our B, and our C. We're going to plug that into our quadratic formula. Okay. My B is -9, my A is -1, and my C is -17. Perfect. My -9 is going to be at +9. See, that's 81. -4 times -1 is +4 times -17 is going to be negative. Let's see, 2 times 17 is going to be 34. It's going to be 68. Perfect. X equals 9 plus or minus square root of 13 all over -2, which in this case, I can't reduce 13 like we did before, so it's just going to stay that. Awesome. So let's get just a few more. Let's do 2 more of those, make sure we got the process down. So again, the big thing that you're going to be doing is you're just going to be finding your A, your B, and your C. A is in front of the x squared, B is in front of the x, and C is the number without x. And you're going to plug it into your formula, which is your vertex, -b over 2a, and you add and subtract the discriminant, which is b squared minus 4ac. In this case, I get -16 plus or minus 256 minus 4 times 3 is -12 times 12 is -144, which in this case is, let's see, that's 1, 1, 2. Okay, so we're going to take a pause and find the square root of 112. Let's see, I know it's even, so I'm going to divide it in half, which is 56, 7 and 8. This looks like a split table, so it's 2 and 4, so I'm just going to go ahead and split it all the way down and circle my pairs instead. Cross out a pair, cross out another pair, which means 2, 2, and the 7 stays behind, which is 4 square root of 7. So the 7 stayed behind, my 2's canceled out, and my other 2's canceled out. So I have x equals -6 plus or minus 4 square root of 7 all over 6. I notice that I have some reduction that can go on. X equals -3 plus or minus 2 all over 2. There we go. That's over the last one. Go ahead, pause the video, give it a shot, resume it when you're done, see how you did. Let's see, A, B, C. Plug it into your formula. And simplify. Don't forget a negative b is a negative negative. It's positive 12 times negative 12 is negative 144 over -6. There we go. In this case, I can actually split. I guess we had a real one slip in there. So I have an x equals 13 plus 5 over -6. X equals 13 minus 5 all over -6, which gives me 18, which is -3. And -4/3. And there we go.